Hello everyone. Today I will discuss about Cauchys root test or Cauchys nth root test. Cauchys root test. If sigma un is a positive term series such that limit n tends to infinity, nth root of un, that is limit n tends to infinity un raised to the power 1 by n is equal to L, then the series converges if L is less than 1, diverges if L is greater than 1. The test fails to give any definite information if L is equal to 1. Proof and case 1. Suppose that L is less than 1. Let epsilon be a positive number such that L plus epsilon is less than 1. Then suppose that L plus epsilon is equal to alpha, which is less than 1. Since limit n tends to infinity un raised to the power 1 by n is equal to L, therefore by definition of this, there exists a positive integer m such that modulus un raised to the power 1 by n minus L less than epsilon for all n greater than or equal to m, which implies that L minus epsilon is less than nth root of un less than L plus epsilon for all n greater than or equal to m. Implies that L minus epsilon whole raised to the power n is less than un, which is less than L plus epsilon whole raised to the power n is equal to alpha raised to the power n, because L plus epsilon is equal to alpha for all n greater than or equal to m. And this implies that un is less than alpha raised to the power n for all n greater than or equal to m. Now since sigma alpha raised to the power n, that is the series alpha raised to the power n, is a convergent geometric series with common ratio alpha less than 1. Therefore, by comparison test, the series sigma un is convergent. Case 2. Suppose that its limit L is greater than 1. Let epsilon be a positive number such that L minus epsilon is greater than 1. Let L minus epsilon is equal to beta, which is greater than 1. Since limit n tends to infinity un raised to the power 1 by n is equal to L, therefore there exists a positive integer m1 such that modulus of un raised to the power 1 by n minus L is less than epsilon for all n greater than or equal to m1, which implies that L minus epsilon is less than un raised to the power 1 by n, which is less than L plus epsilon for all n greater than or equal to m1. Implies that beta raised to the power n equal to L minus 1 raised to the power n, where L minus epsilon is equal to beta less than u n less than L plus epsilon whole raised to the power n for all n greater than or equal to m1. This is m1. Implies that un is greater than beta raised to the power n for all n greater than or equal to m1. Now, since sigma beta raised to the power n is a divergent geometric series with common ratio beta greater than 1, therefore, by comparison test, the series sigma un is divergent. Case 3. Suppose that L is equal to 1. Consider the two series sigma 1 by n and sigma 1 by n square. The series 1 is divergent and the series 2 is convergent. However, limit n tends to infinity un raised to the power 1 by n is equal to limit n tends to infinity 1 by n raised to the power 1 by n is equal to 1. Here, in this case, un is equal to 1 by n. And limit n tends to infinity 1 by n square raised to the power 1 by n is equal to n. Thus, we have examples of two series for each of which limit n tends to infinity un raised to the power 1 by n is equal to 1. But while one series is convergent, the other series is divergent. Example 1. Test the convergence of the series whose general term is 1 plus 1 by square root of n whole raised to the power n raised to the power 3 by 2. Let un is equal to 1 plus 1 by square root of n whole raised to the power n raised to the power 3 by 2 is equal to 1 by this quantity 1 plus 1 by under root 2 whole raised to the power n to the power 3 by 2. Then limit n tends to infinity un raised to the power 1 by n is equal to limit n tends to infinity 1 by 1 by square root n whole raised to the power square root of n is equal to 1 by limit n tends to infinity 1 plus 1 by square root of n whole raised to the power square root of n is equal to 1 by e, which is less than 1. Because value of e is equal to 2.71, so 1 by e is less than 1. Hence, by Cauchy's root test, the series converges. Example 2. Test the convergence of the series sigma n is equal to 1 to infinite 1 plus 1 by n whole raised to the power minus n square and sigma n is equal to 1 to infinite n raised to the power n square by n plus 1 whole raised to the power n square. Solution. First part. Here un is equal to 1 plus 1 by n whole raised to the power minus n square is equal to 1 plus 1 by n whole raised to the power minus n whole raised to the power n. Therefore, n tends to infinity un raised to the power 1 by n is equal to limit n tends to infinity 1 plus 1 by n whole raised to the power minus n is equal to limit n tends to 1 by 1 plus 1 by n whole raised to the power n is equal to 1 by e is less than 1. Therefore, by Cauchy's root test, the given series is convergent. Second part, in this case, un is equal to n raised to the power n square by n plus 1 whole raised to the power n square is equal to this. Therefore, limit n tends to infinity nth root of un is equal to limit n tends to infinity n by n plus 1 whole raised to the power n is equal to limit n tends to infinity 1 by 1 plus 1 by n whole raised to the power n is equal to 1 by e is less than 1. Therefore, by Cauchy's root test, the given series is convergent. Example 3. Examine the convergence of the following series. Number 1, n is equal to 1 to infinite nx by n plus 1 whole raised to the power n, and second, n is equal to 1 to infinite 1 plus nx by n whole raised to the power n. In the first part, un is equal to nx by n plus 1 whole raised to the power n, which implies that nth root of un is equal to nx by n plus 1. Therefore, limit n tends to infinity nth root of un is equal to limit n tends to infinity x by 1 plus 1 by n is equal to x, because limit n tends to infinity 1 by n is equal to 0, and this whole quantity is equal to x. Hence, by Cauchy's root test, the given series is convergent if x is less than 1 and divergent if x is greater than 1. Now, when x is equal to 1, the Cauchy's root test fails. So, limit n tends to infinity un is equal to limit n tends to infinity 1 by 1 plus 1 by n whole raised to the power n is equal to 1 by e, which is not equal to 0. Hence, the given series is divergent. Because the necessary condition for a series to be convergent is limit n tends to infinity when must be equal to 0. Since limit n tends to infinity un is not equal to 0, therefore the given series is divergent. Thus, the given series is convergent if x is less than 1 and divergent if x is greater than or equal to 1. So, this is Cauchy's root test and some of its examples. Thank you very much for watching this video. Please subscribe my channel. Please like, share and comment on this video. Please press the bell icon to get notifications.